Hello and welcome back to another episode of Technical Tuesdays. This is the series where we explore how the different parameters of injection moulding can affect the final part or product. In this episode, we're going to explore how the different runner systems will affect the part that we're producing. We covered mould tools in our last episode, which has some great information that will give you the context you need for this episode. Go back and watch it if you haven't already. So we know that mould tools give the part its form and shape, and runners are the systems that channel the molten plastic from the barrel into the mould. We also know that there are two main types of runner systems, hot and cold. But what are the differences and how do they affect the part that we're producing? A cold runner system is simply a channel that allows the molten plastic to pass through the mould tool, connecting the barrel of the machine and the gates inside the mould, which finally fill the cavity inside the mould tool. A hot runner system consists of heated components inside the mould tool, which channel the molten plastic from the barrel of the injection moulding machine into the cavities of the mould tool. Hot runner systems use electricity to heat the elements which keep the molten plastic at melt temperature before entering the core and cavity. The size of the hot runner channel depends on a few factors, like injection speed, polymer type, and the size of the part being produced. A temperature controller is required to heat the elements inside the runner system, which is usually controlled by the injection moulding machine. Using this tool as an example, which makes light fixtures designed to replace their metal counterparts, the cold runner system is essentially a channel or channels that guide the molten polymer from the barrel through to the mould tool and into the gates which feed the core and cavity. Because there's no secondary heating element in the tool, the sprue also cools as the moulding cools, which has to be removed along with the part. With cold runner systems, because the molten plastic cools in the mould, it also means that the polymer in the runner system cools as well. Because of this, you will see the barrel retract between each cycle, allowing the sprues to be removed. With hot runner systems, like this tool which produces the front case for an electronics enclosure, the molten polymer passes through a similar style of runner system to a cold runner. However, the biggest difference is that when the polymer gets to the runner tip, it's reheated before passing through the gates and into the mould core and cavity. This means that any polymer left in the runner system remains molten, ready for the next injection, and does not have to be removed along with the part. For the same tool design, a cold runner system will be the cheapest and easiest to maintain. Cold runner systems will also use less energy than their heated counterparts. As a manufacturer, this can be an attractive option, especially in today's energy climate, albeit a minimal saving compared to the energy used by the machines. The downside to cold runner systems is that they are less reliable and accurate compared to hot runner systems. There can be more variation between shots, which can lead to higher scrap rates when producing parts with tight tolerances or high-spec surface finishes. Another factor to consider is the cycle time required to produce the same part with a cold and hot runner system. As cold runner systems leave behind a sprue that must be removed by either an operator or an automated system, the extra time taken to remove the sprue may only be a few seconds longer than a hot runner system, but the seconds quickly add up when you're producing hundreds or even thousands of parts. Hot runner systems offer many benefits, like the ones already mentioned. They also offer more leeway with tool design, allowing for better gate options and positions to be explored, meaning you can get the most out of the product that you're producing. As mentioned before, because no sprue needs to be removed between each cycle, you can have a faster cycle time with hot runner systems. This will end up saving you a lot of time when producing hundreds, thousands, or even millions of parts. One downside to hot runners, beside the energy usage, is the maintenance of hot runner mould tools. With cold runner systems, the issue can usually be rectified with machining or EDM machining. Because of the complexity of hot runner systems, the maintenance can take a lot longer and be more expensive. So that wraps it up for our episode on mould tool runner systems. As always, we hope you've learned something. If you have any comments, questions or suggestions, let us know down below. Other than that, we hope to see you all in the next episode.